a sky the color of rust at 2 in the afternoon. In June of 2023, that was not a filter or a sunset. It was Tuesday in New York City, 600 miles from the nearest flame. Smoke from wildfires burning across Canada had drifted south and turned the air toxic from Toronto to Washington. Millions of people who had never seen a wildfire in their lives were suddenly breathing one. That single afternoon became the image of 2023, but it was only a symptom. The actual fire season behind it was the most extreme Canada has ever recorded, and it is worth understanding why. Canada holds roughly a third of the entire planet's boreal forest, an unbroken band of spruce, pine, and fir circling the top of the globe. Fire is not a stranger there. Some tree species even need fire to crack open their cones and release their seeds. For centuries, indigenous communities used controlled seasonal burning to manage that land, clearing undergrowth before it could fuel something worse. That practice was suppressed in the early 20th century, replaced by putting out every fire fast, which let unburned fuel quietly pile up for decades. So the real question is not whether Canada's forests burn. It is why one single year burns so much more than any year in over 50 years of record keeping. Have you ever wondered how a fire big enough gets so hot that it starts making its own weather? Under the right conditions, a wildfire can punch smoke and heat so high into the atmosphere that it forms its own thunderstorm, called a pyrocumulonimbus. It can generate real lightning, and in rare cases even a fire-driven tornado. In 2023, Canada logged well over 100 of these fire-generated storms in a single season, accounting for the large majority of everyone recorded on the entire planet that year. Once a fire reaches that scale, it stops behaving like a campfire that got out of hand. It becomes a self-sustaining weather system that can throw embers kilometers ahead of the flame front, igniting new fires before firefighters even arrive. None of that happens without the right ingredients lining up first: dry fuel, low humidity, high wind, and heat. Take away any one of them, and a spark just fizzles out. In most years, those ingredients line up in one region of Canada at a time. What made 2023 different is that they lined up almost everywhere at once, from the Pacific coast to the Atlantic, for months. An unusually warm winter meant large parts of the country lost their snow cover weeks earlier than normal, exposing dry ground to the sun much sooner than usual. Western Canada was already carrying drought over from the previous year, and when the snow disappeared early, the soil there had almost no moisture left to spare. Eastern Canada told a different but equally troubling story. The ground started the season with roughly normal moisture, but unusually hot, dry weather sucked it out in a matter of weeks, a pattern scientists now call a flash drought. Either way, you arrived at the same result. By late spring, forest floors across almost the entire country were primed to burn. So how unusual was the heat itself, really? 2023 was, at the time, the hottest year ever measured globally, and Canada felt it especially hard. Fires need more than dry fuel, they need a spark. In Canada, the overwhelming majority of the area that actually burns is ignited by lightning, not by people. Curiously, 2023 did not even have an unusually high number of lightning strikes. What it had was extraordinarily dry ground waiting for exactly those strikes, so a much larger share of them caught and grew into major fires. A handful of specific lightning outbreaks on just a few days in May and June ended up responsible for a striking share of everything that burned across the entire season. Picture the jet stream as a giant river of air that normally keeps weather moving along. Sometimes it gets stuck, forming what meteorologists call a blocking pattern, trapping hot, dry air in place for days or weeks instead of letting a cool front reset things. In 2023, these blocking events over Canada were far more frequent and far longer than the historical average, locking in fire weather across huge stretches of the country for the entire summer. This is where climate scientists reach for a specific and fairly young field called event attribution. Instead of just saying an extreme event fits a warming trend, researchers rerun climate models with and without human greenhouse gas emissions to ask a sharper question. How much more likely, or how much more intense, did human-caused warming make this particular event? It is the same method that let scientists calculate that the infamous 2021 heat dome, which baked the Pacific Northwest and helped trigger one of British Columbia's worst fire seasons on record, was made roughly 150 times more likely by climate change. So by the time 2023 actually began, scientists already had good reason to suspect climate change was loading the dice. What they still needed was a complete, verified accounting of the season itself. Because here is the thing about a wildfire season: while it is still happening, the numbers being reported in real time are almost always rough estimates. Agencies on the ground need to make fast decisions, so early figures come from active fire perimeters that have not yet been checked against lakes, rivers, or patches of forest that never actually burned inside the fire's rough boundary. So a team of fire scientists at Natural Resources Canada built a properly verified picture of the season instead, combining high-resolution Landsat and Sentinel satellite mapping with thermal hot spot detections, cross-checked against water bodies and unburned islands to correct for overcounting. They layered that fire map against weather data covering the entire country since 1940, drought indexes built from soil moisture satellites, and Canada's national database of every wildfire evacuation since 1980. So, after all that verification, just how much worse was 2023 than any fire season Canada had ever recorded? About 15 million hectares of forest burned between mid-April and late October, an area larger than the entire country of Greece. That is more than double the previous record of 7 million hectares set back in 1989. 4 provinces and territories, Quebec, the Northwest Territories, British Columbia, and Alberta, each posted their single worst fire year ever documented, all in the same 12 months. One individual fire complex alone burned through more than 1 million hectares by itself, the largest single fire recorded in the country since 1950. The heat behind it was just as extreme as the fire itself. Average temperatures across the May to October fire season came in 2 degrees Celsius above the normal baseline. Researchers noted that gap is already close to what climate models project as an ordinary summer for Canada by around the year 2050, under a high-emission scenario. In other words, the models are running about 25 years ahead of schedule. Fighting fire on that scale broke Canada's response system too. The country declared its highest possible national alert level, meaning domestic firefighting resources were no longer enough on their own, and kept it in place for a record 120 straight days. Over 5,500 firefighters from 12 countries and the European Union flew in to help, on top of more than 1,700 personnel redeployed from other parts of Canada itself. The human toll went well beyond the firefighters on the line. Roughly 232,000 people were evacuated across 282 separate events, the highest number of evacuees of any fire season since national records began in 1980. Some towns had to be evacuated twice within the same year. 8 firefighters lost their lives over the course of the season. Air quality agencies issued roughly 5,000 smoke-related health alerts in 2023 alone, compared with an average of about 1,300 a year over the previous 5 years. Some regions spent more than 60 days breathing air that failed national health standards. And the forest itself is not simply expected to grow back the way it was. More than 1 million hectares of young forest, stands too immature to have built up a seed bank yet, burned in 2023. Researchers estimate that hundreds of thousands of hectares of Quebec's commercial forest alone may fail to regenerate naturally as a result, since there were no mature trees left standing nearby to reseed the burned ground. Combined with decades of logging, ongoing drought, and insect outbreaks, that kind of regeneration failure can gradually push boreal forest toward open grassland or shrubland, instead of ever growing back as forest at all. The researchers behind the analysis are careful to call their work a description of what happened, not a formal attribution study proving climate change caused any single fire. But taken together with the blocking patterns, the record heat, and the studies that already traced 2021 and Quebec's fires back to human warming, the pattern is hard to ignore. Their own conclusion is direct. Extreme heat and moisture deficits enabled this record-breaking season, and if fire activity keeps increasing as current trends and projections suggest, 2023 may end up looking less like an outlier and more like a preview.